All right, so here we are with part 2 of this, and what are we doing here? Oh yeah, we're doing linear programming. So I'm going to read a problem, find something going on in there, find an objective that we want to do, either to maximize or minimize, build some constraints that are the limitations on that scenario, and then solve. All right, so let's go ahead and start at the beginning, because that's the best place to start. Thomas plans to start a new business called River Explorers, which will rent canoes and kayaks to people to travel 10 miles down the Clarion River in Cook Forest State Park. He has $45,000 to purchase new boats. He can buy the canoes for $600 each and the kayaks for $750 each. His facility can hold up to 65 boats. The canoes will rent for $25 a day and the kayaks will rent for $30 a day. How many canoes and how many kayaks should he buy to earn the most revenue if all boats can be rented each day? All right, so it looks like this right here is going to define our variables. So let's do that. I'm going to say that X is going to be the number of canoes, and then Y will be the number of kayaks. Okay. Let's see. I need some inequalities and I need an objective. Now, the objective was stated here. Earn the most revenue. So that means that my objective is to maximize revenue. Okay? And if my objective is to maximize revenue, then when I build this equation, I know this is going to be my revenue equation. So how much revenue will I earn? Well, I earn $25 a day times the number of kayaks that I'm going to have, and I earn canoes, and I earn $30 a day times the number of kayaks that I have. And there's my revenue equation. That's the thing that I want to maximize. Well, what are my constraints? Well, reading through the problem, I'm thinking that my constraints are I have $45,000 to purchase, and my shop, I'm saying my Thomas's facility can hold 65 boats. Right? So I think my constraints are going to be the purchase price. I don't want the highlighter. I'm sorry, I need to go back to my blue pen. The purchase price and the storage. Okay. So the purchase price tells me that a canoe costs $600. So $600 times the number of canoes I buy, plus the $750 per kayak times the kayaks I buy, has to be less than or equal to $45,000. Because I don't have to spend it all, I just need to spend some of it. The storage says I can only have room for 65 boats, so the number of canoes plus the number of kayaks cannot exceed 65. And then I've got this, X and Y both must be greater than or equal to 0, the non-negative conditions. And for this problem, it's really clear also that X's and Y's here can't be halves. They have to be whole numbers because it's the number of canoes and the number of kayaks. All right, so now that I've got my constraints and my objective function figured out, I'm going to go ahead and sketch the graph of the feasible region and go from there. Okay, so in order to graph the feasible region, I need to find those boundary lines and do all that business. So I know this much. I know that the first quadrant is all that makes sense here because of that non-negative condition. I know that the second, because I'm lazy, I'll do that one first. The second boundary line there, so the boundary line for the second one, X plus Y equals 65, is going to have a 65 for the x-intercept and also a 65 for the y-intercept. The boundary line for the other one, now that's going to be the tricky one. The boundary line for the first inequality is going to be 600x plus 750y is 45 grand. And so the x-intercept is going to be when y is 0. The y-intercept is when x is 0. So this number right here is going to be when y is 0. So if I make y be 0, it'll be 4,500 divided by 600. So 4,500 divided by 600, I'm using my calculator, I get 7.5. Nope. And then the y-intercept is going to be the 4,500 divided by 750. And that gives me 6. You know what? I just realized something. Isn't this 45,000? So I think this one's actually going to be 75 and 60. And those numbers make so much more sense. I love when I make mistakes like that. Actually, what I love about it is when I catch it, because those numbers just seemed way too small. All right, so let's go ahead and sketch these things. Purple, purple, 65, 65. Looks like my x-axis needs to go out to 75. So if I put 75 out there, that will be 25 and 50. My y-axis needs to go up to 65. So if I put 60 about there, that would be 30, 10, 20, 40, 50, 65. And it needs to go from 65, which would be about there, to 65, which is about there. And I want less than 65, so I want this inside region right here. Okay. The non-negative conditions down here force it to be just the first quadrant, so I don't have to worry about anything outside of that. So I'm just down to that triangle. Now I'll graph that other boundary line. The other boundary line goes from the 75 on the x-axis to 60 on the y-axis. And for that one, I also want the less than, so I want under it. So it looks like I'm going to end up with one corner somewhere about there-ish, and I'll make that dot nice and big because I'm not sure exactly where it is. And then my feasible region is going to be this right here. Now I know there's at least one person out there saying, I can't do this that well. Feel free to throw this thing into Desmos and make it happen that way. I'm okay with that. I just like drawing these things because I paid a lot for this pen, so I want to do it. All right, so I need to find out what that corner is. Now that corner is the intersection of those two boundary lines. So I'm going to need to do some math down here. I need to find the solution to the system where those two boundary lines intersect, which is going to be the system x plus y equals 65 and 600x plus 750y equals 45,000. So I'm going to grab my calculator, go to my matrix, over to edit. That's a 2 by 3 matrix, so it's going to be 1, 1, 65, 600, 750, 45,000, quit out of there, RREF, 25, 40, so I get that x is equal to 25, y is equal to 40. So when I come back up here and I take a look at what's going on, I've got 3 corners, 1, 2, 3 that I care about, 1 that I have to do because it's there. I'm going to label them A, B, C, and D. A is the corner 0, 60. B is the corner, what did we just say it was, 25, 40. C is the corner. Where'd that hit down there? Was that 65? 65, 0. And D is the corner 0, 0. So now we'll evaluate the objective function in each of these corners and decide which one does what we want it to do. In this case, maximizes our objective function. So in corner A, Z is going to be equal to 25 times 0 plus 30 times 60, 180, but this is our revenue, so we're measuring it in dollars, $180. For corner B, Z is equal to 25 times 25 plus 30 times 40, which is equal to, let's see, 25 times 25 plus 30 times 40, and I get 1,825. The reason I'm remarking that that seems odd is that number is so much bigger than the other one. But 6 times 3, there's my mistake. This is 1,800. That looks better. Okay. It's been a very, very long day and I'm very tired. Right? Corner C. Corner C, the Z is going to be equal to 25 times 65 plus 30 times 0. So 25 times 65 is 1,625. And then, of course, I have to do D just because it is a corner, but it's going to be 0. Okay? D represents buying nothing, and if you buy nothing, your revenue is going to be nothing. Okay? I'm looking for the biggest one. I think that's the biggest one, right? So the final answer here is, and what's the name of this guy? Robbie? Thomas. Thomas should buy, what should he buy? 25 X's, which were canoes, and 40 Y's, which were kayaks, for a max revenue of $1,825. And it wasn't that revenue per day? That's pretty good. I wouldn't mind making $1,800 a day. I mean, I know it's revenue, not profit and all that, but still, it seems like a pretty good number. All right, I'm going to call this video here. We'll come back and do part 3 where we'll answer the very, very smoothies question. And that will be the last part.